Hey everybody, this is the video for, I guess technically you can say 4 sections at once. Seems like a lot, but it really isn't. You know, I mean, any Algebra 1 textbook would have maybe all of these just in their own like separate section, just kind of doing like a little bit at a time, and having a progression as the inequalities get a little bit different or a little more complicated or whatever. But it's going to be very easy to kind of do what a lot of textbooks consider 4 separate sections, all at once. It's not going to be too tough for us, especially considering this is probably not the first time in your math careers that you've worked with these topics. So let's dive right in. So we've been solving equations. We've been working with equations, but obviously this thing here in blue and this thing here in purple, you can't really call equations as simple as they are. I mean, I know normally equations have a variable, but just to kind of make it so simple, like as simple as maybe possible, just to have something like 8 on one side and 3 on the other. These are obviously not equal. So this is one thing you could say. 8 is not equal to 3, and 5 is, not equal to 9. Those are true. Those aren't wrong symbols. But when we're looking to talk about inequalities, okay, we want to use, remember the alligator mouth thing? So you could say that 8 is not equal to 3, or you could say that 8 is greater than 3. So that's a greater than symbol. You will probably recall. Remember, the alligator mouth wants to eat the larger number, so it's facing the 8. And so therefore, since you say 8 is blah blah blah, then 3, you say, you obviously read this from left to right, then this symbol is always known as the greater than symbol. And then similarly, you could say, again, what I had originally is not wrong. You could say 5 is just not equal to 9. Or you could say, obviously, that 5 is less than 9, because it is. And so therefore, the symbol would be just like that, opening its alligator mouth towards the 9. And that would be obviously known as a less than symbol. So next quick little thing. Just want you to remember what a solution is. A solution, so we were just working with solutions to equations in recent days and recent sections. And a solution to an equation, remember, is any number that replaces the variable to make the equation true. So never forget that. Never forget what a solution actually is, like as kind of like a definition. It's just any number that could replace the variable to actually make the equation true. Do we also have solutions for inequalities like this? Would this still have a solution? Meaning just anything that could replace the x to make this true, to actually make whatever -4 actually truly less than 3? Yeah, inequalities can also have solutions. Is 10 a solution? Just like this, it's kind of written out for you already. If we replace the x with 10, does that now make this true? Is 10 minus 4, in fact, less than 3? Well, no. 10 minus 4 is not less than 3. So that means 10 is not a solution. Is 6 a solution? Meaning, is that true? Is 6 minus 4 less than 3? Well, yeah. So 6 is a solution. Is 7 a solution? If you do 7 minus 4, is that going to be less than 3? In other words, is 3 less than 3? Well, no. 3 is not less than 3. 3 is equal to 3. So, well, moving on. Are there any others? So we know 6 is a solution. Are there any others? Would there be any other number that you could plug in for x, and then that number minus 4 would be less than 3? Sure, there's plenty of them. You know, how many of them are there? Well, there's an infinite number. There's an infinite number of numbers that could plug in for x to make this whole inequality a true statement, right? But so there's an infinite number of solutions, but does that mean all real numbers are solutions, like literally any number? Well, no, because obviously we just literally saw that 10 is not a solution, and 7's actually not a solution, right? But there's an infinite number. What's the largest one? Because you might have thought, like, well, you know, 0 is a solution. Negative 10, like, you know, basically negative anything, you know, minus 4 is going to be less than 3. You know, like, so we saw 6 was a solution, and again, you know, 5 and 0 and everything like that. But then we saw that 7 was not. Does that mean 6 is the largest of the infinite number of solutions? Like, what's the largest one? Is it 6? Because 7 didn't work out, and obviously 8 wouldn't work out, and 10 and 100. Is 6 the largest answer? If you're thinking yes, then you're probably forgetting about numbers like, oh, I don't know, 6.5, right? 6.8, 6.9, heck, 6.999. I mean, when could I stop? So yeah, numbers like 6.5, you know, those would be solutions. And so what's the biggest one? Like, you may get, well, 6.9999999. Well, I mean, okay, but you could always name one bigger. And so when we have to show this using a number line, like literally graph this answer using a number line, you know, all of these are like 6 is a solution. And when I mentioned 0, all of these negative numbers, like anything, right? But then also like 6.5 and 6.9. So how do we like graph this? Well, what we can do is we can put an open circle right on the 7. And we can leave it open to kind of represent that, well, 7 is not actually a solution. We're not coloring it in. We're leaving it empty. We're putting like an empty dot on the 7, and then we can kind of shade or put a line or whatever your style is heading to the left with like an arrow on it. So this is the graph of basically anything less than 7. If we were to, I mean, I'm getting a little ahead of myself, I guess, but if you were to solve this for x, like just like we were doing with equations, get x by itself, like by what? Adding 4 to the other side or adding 4 to both sides, you would get x is less than 7. And this describes all the solutions. Anything that's less than 7, just not 7. As long as it's less than 7, just not hitting 7, then it's a solution. And so that covers, you know, 6.999 and even things that are even a little bit more than that, but still less than 7. And okay, so that's the graph. All right, moving on. Hopefully I covered that enough. But consider, what if we made it not, remember, these symbols exist, you probably already know. There's less than symbols, but then this is a less than or equal to. So now is 7 a solution? Because, you know, 6 would still be a solution, and 0 and all that stuff. But would 7 now be a solution if we plugged it in and we got 7 minus 4 is less than or equal to 3? So in other words, is 3 less than or equal to 3? Well, yeah, now it is true. Because 3 is equal to 3, that's less than or equal. So if we were to then, again, just to be thorough here, if we were to like literally get x by itself, just like we do with equations, and add 4 to both sides in order to get x all by itself, you'd have that. And so when we have x is less than or equal to 7, now we're going to actually color in the circle, because now we're actually graphing 7 along with everything, less than 7, also equal to 7. So remember, again, should be review for just about everybody, if not everybody. And remember, so symbols like this, when it's a less than or equal to, or a greater than or equal to, whenever there's an or equal to line, pretty much like half an equal sign, basically, that's when you color in the circle. But when it's just a less than, or when it's just a greater than, you have to put an open circle on that number, which you'll see as we do example after example after example. I don't know, we're only doing a couple examples on this handout, but so just a couple examples here. We have to solve first. See, in order to get our solution, basically, as well as the graph, we just have to get x by itself. I don't think I need to reteach that. I mean, these examples will kind of review it a little bit. The steps are going to speak for themselves. So I'm going to subtract 5 from both sides first. So that'll take care of that. And then that'll make the inequality just now 2x on the left side. And then we, again, you're probably one step ahead of me here, at least in your brain. So then we would divide both sides by 2. And that finishes getting x by itself. And now that we have that, again, x by itself, now we can go, well, everything that's greater than or equal to 4. So that means we're going to color in the 4. Okay. Next one. Again, hopefully you're one step ahead of me in your head here. We're going to, distribute first. Okay. Let's line up that symbol. So 5 times x, 5 times negative 1, we distributed. I mean, now what do? We have an x on both sides. We have to move one of the x's to the other side, so we only have x on one side. And yep, I saw that coming. Hopefully you did too. Moving the smaller x, so we're subtracting. So now the right side is just going to be a negative 3. 5x minus 4x is just x, or 1x. Then to finish getting x by itself, we're going to add 5 to both sides, and so that leaves x all alone. And the other side becomes what? 2. So in a way, the final answer is this: x is greater than 2. Meaning everything just greater than 2. Not equal to 2. So we're not going to color it in, but again, we have to put the graph kind of circle right on the 2, because that's how we kind of show that literally, just not 2, but literally everything greater than 2, including 2.001 or even 2.000001. And so that's what we do. We just put an open circle right on 2 and then shade literally everything. Not just 3 and 4 and 5, but 2.5 and 2.1, 2.0001, and all that jazz. Next, a quick little investigation, kind of like an experiment that hopefully makes you discover or rediscover or reinforce something that you've already seen coming here. But hopefully a little discovery or rediscovery of a concept here with inequalities. So hopefully everyone agrees that this is true. This is a true inequality. 4 is less than 6. We know numbers. So obviously, how we can do things to both sides. We were just doing it. Subtracting 5 from both sides, dividing both sides by 2. As long as you do the same thing to both sides, you're allowed to do that in an inequality, or so it seems. Here we go. Let's see. Is the inequality still true if you multiply both sides by 2? Well, if we do that, I believe we're going to get 8 on the left and now 12 on the right. Is this still true? Yeah, still true. What if we divide both sides by 2? If we do it by 2, I get 2. Divide by 6 by 2, I get 3. So is that still true? Yeah. If we divide both sides by -2, well, that'll make that a -2, and then this would become a -3. So is this still true? Is -2 less than -3? Well, no. It's not true anymore. And why is that? Well, it's just how negative numbers are, you know? It's how, like, if you have, again, I mean, what is there to say? You know, if, like, what's bigger, 10 or 1? Well, 10 is bigger. But if I made them both negative and said, which one's bigger, -10 or -1, you'd have to say -1. So again, when it comes to like less thans and greater thans and what number's bigger with negative numbers, it's just how it goes. So if you multiply both numbers by both sides by -2, it's not true anymore. And if I wanted to make this true, I'd have to actually just reverse the symbol, you know? And it's the same thing when we divide both sides by, say, -2. You're going to get a -2. Oh, I'm an idiot. I totally... Okay. Well, hopefully it's an easy fix for you. That's the division. If I multiply, my bad, I would have got a -12. But it's the same thing. What, a -8 multiplying? That's embarrassing. At least I caught myself, or caught my mistake eventually, after an awkward amount of seconds. But the point is, same thing. -8 is not less than -12. -8 is greater than. So the bottom line is, and this is something you might want to write down in some space or a margin, or at least make a very strong mental note, for goodness sake. Whenever you multiply an inequality, like both sides of an inequality, by something negative, you have to flip the symbol for it to stay true. So multiplying or dividing both sides by something negative means you have to flip the symbol. So let's see this in action. Looking at this, what would you do first on your way to getting x by itself? Well, I hope you understand that this 4 that you need to move out of here is a positive 4, so you have to subtract 4 from both sides, which is going to leave a -3x on this side. That negative is with the 3x. And so what's next? Well, hopefully, again, you're one step ahead of me in your brain. We're going to divide both sides by -3. So this side becomes -4. Sorry, +4. Crap, I was expecting... Man, too many mistakes here in my explanations. But -12 divided by -3 is +4. And when, you know, I divide the left side by -3, all that's going to happen is getting the x all alone. But whenever it's a negative number you're dividing by on both sides, you have to reverse the symbol. So I had to flip that. So actually, you know, the final answer is anything that's less than or equal to 4. So again, it's or equal to 4, so I'm coloring that in. But the proper graph is going to be shading to the left. Okay? So again, that's pretty much it. So in conclusion, you should listen to this before you stop the video. So in conclusion, right, solving inequalities compared to what we've been doing for a bunch of days here, solving equations, it's like literally the same thing. Literally the same thing. You just get x by itself by doing whatever, all those little moves to both sides or distributing or all that stuff. It's literally the same, except with inequalities, there's technically, you know, usually or always going to be an infinite number of solutions instead of the usual one solution. Equations usually only have one solution. Inequalities almost always have like an infinite number of solutions. So that's one difference, which means oftentimes with inequalities, you're going to be asked to include like a little number line graph to to represent all the infinite solutions that are usually, there. So that's one big difference. And the other big difference is you just got to remember with inequalities that whenever you find yourself multiplying both sides by something negative or dividing both sides by something negative, you immediately on the spot have to flip the symbol. Okay? As long as you remember that, you'll be good to go.